Every gas which is produced is having a test. Like for example, if I want to test oxygen, what do we use? A glowing splint. Have you ever heard of it? Yes. That oxygen rewrites a glowing splint. If I'm testing hydrogen gas, I use a burning splint. That hydrogen burns with a popping sound. You understand? If I'm testing carbon dioxide, I use lime water. Carbon dioxide turns lime water milky. Now, if I'm testing sulfur dioxide gas, I use those chemicals. It is called acidified potassium dichromate or acidified potassium permanganate. Now, those are just substances, though we don't have them here, but those are just substances. Whereby this one is orange, is an orange solution. You understand? Dichromate, then permanganate, it is a purple solution. Let me assume, this one I just want, we are saying sulfur dioxide, I can test it using a litmus paper. And as still I'm going to talk about it. But we have other tests we can use. Like for example, we have very many gases which can turn a blue litmus paper to red. You understand? But I also have other substances which can confirm, like for example, sulfur dioxide, it is the only one which can have an effect on these substances. So giving only a litmus paper may not be enough. That is also part of it. Now, I'm saying, let me just give an assumption. Are you there? Like for example, let us assume this is the potassium dichromate. I'm assuming. Are you there? And I'm saying the potassium dichromate solution, it is orange. Now, if you produce your sulfur dioxide and you bubble it here, that orange solution changes to green. If you see that observation, you confirm that the gas you have bubbled there is sulfur dioxide. Have you got it? No. I'm saying, if we assume this is the potassium dichromate, I want to test whether I've produced sulfur dioxide. If you get this potassium dichromate, which is an orange solution, and you bubble there sulfur dioxide, the orange solution changes to green solution. If you see that observation, you confirm that that is sulfur dioxide. Now, if it is not potassium dichromate and I'm using potassium permanganate solution is a purple solution. You understand? Still, if you bubble there sulfur dioxide, the purple solution changes to colorless. You understand? Still, if you see that observation, you confirm that is sulfur dioxide. Now, those things I've talked about is what I'm going to put here in my observation when I'm making an observation. How? This is what I'm going to say. Number one, you finished to give an observation on the rate of crystallization. You gave an observation on the color change of the substance. Now I'm giving an observation on the gas produced. You understand? Still in that same table. Actually, most of the time for the heating part, they leave a big space. You understand? Now, what am I going to say? I'm going to say that I want to talk about sulfur dioxide. I will say a colorless gas. Even if I don't put the word which, and I just put a comma and I say turns moist blue litmus paper, red, because we say that one is also a test. Then I say turns acidified potassium dichromate solution from orange to green. You understand? Or someone can use the potassium permanganate and say from purple solution to colorless. And you stop there. You have talked about, you have seen a colorless gas, which turns a litmus paper red. Then which turns acidified potassium permanganate from orange to what? To green. Now, this is what will happen. If someone just gives an observation only for the litmus paper, you will get only this mark. This one and this one. You get it? So what I'm trying to say that the more points you give, the more marks you get. Someone can say a colorless gas turns a moist litmus paper red. You stop there. You have your marks. Then another one gives this one plus this one. This one will be getting more marks. You understand? Yeah. Then after that, we are giving a conclusion. We are giving a conclusion. So what is, so we are saying, so we want to make a conclusion. What will be the conclusion? Number, so the gas which is the time, it is what?
Sulfur dioxide.
So you are going to say sulfur dioxide, but not present, evolved. You understand? The word, another word for, if you don't use the word evolved, you can say given out. You understand? Or even if you don't talk about it, it is also okay. I will say sulfur dioxide. Then the anion present is what? Sulfate. Are you getting me? So the key word here, I'm marking sulfur dioxide, which is giving this observation. Then the anion present is that. You understand? Or someone can bring it like this. First, I can write it like this. I say that sulfur dioxide evolved. Are you there? Then sulfate ions suspected. Here I cannot put the word the confirmed or what, because I'm just suspecting. So I can say evolved, then this one is what? Suspected. Are you there? Yeah, but these are the main. So this is what you need, main. Acidic gas present. Now, which acidic gas? So, but you give this. Because now, if you say acidic gas present, when you have given this observation, now the deduction may not be connecting with the observation you have given. Because when it's acidic gas, there is carbon dioxide gas. Yet the observation you have given is not connecting with the carbon dioxide. But here you try to be specific. Sulfur dioxide, because it is connecting with the observation you have given. You understand? But you may not be able to give these observations if you have started with the heating. No, you can't be able to give that because you don't know whether sulfate was there. Because this one I'm talking about acidified potassium dichromate, you don't do it practically to see. You must be knowing it. You understand that? You not be able to do the practical part of acidified potassium dichromate to see the orange to green. No. That one I'm talking about it because I already know. It is sulfur dioxide doing that. You understand? So to be able to give all the observations on heating is you after doing other numbers. Let us go to another thing. Can I create? It's fine, eh? Okay. Now, observation, reduction. Can you go to the part of dissolving? I think we got someone from this group. So in this group here, can I get someone to dissolve for us? Actually, what we do, let us pick one person in every group. You can dissolve your substance. One person in every group. Eh. Okay, it's okay. So everyone will get a test tube, you get a sample, you dissolve. Can you do that? Water is there, eh? Sorry? We are dissolving. Add this of water or spatula in full. Excuse me, first wait. Can you first wait a bit? Someone should get for me some water. There is water here. I want to do a demonstration before you dissolve also. Eh? Hello, are we together? Now this is what you need to do. Or this is what you need to know when we go to the part of dissolving. When we are dissolving a substance, we can use two things. Are you there? Number one, you can dissolve a substance using an acid. You can also dissolve a substance using water. There are substances which cannot dissolve using water. Actually, all carbonates don't dissolve using water, apart from very few. So if I'm having a carbonate and they tell you to dissolve with water, it may not dissolve. Though what your neighbor does, it brings a mixture. One can dissolve, another one doesn't dissolve. They tell you go and dissolve. You dissolve, you see substance is not dissolving. Yes, there is one which is dissolving, and then there is another one which is not dissolving. Are you there? So, but what you need to put in mind, when we are dissolving, I can dissolve using an acid, and I can also dissolve using water. So that is one. Number two, when you are carrying out dissolving, we use long or these boiling tubes. We don't use the smaller ones like these ones. You understand what I'm saying? Why? Because this substance you are going to get, you are going to divide it into different portions. You understand? And then some substances, when you dissolve, there is adding some chemicals and you get a precipitate. So the smaller test tube may not be so effective when you are dissolving. So we use the longer test tubes. I don't know if we have some which are longer than this. Okay. Now, for now, they are of the same size. But if you are in UNEB and what, try to use the longer test tubes, or you can use a boiling tube. You know, boiling tube. So it's bigger than this. So that is one. Then I told you, you don't supposed to use a lot of chemicals. You understand? Yeah, you don't need to use a lot. So use a little bit. If you are dissolving it in water, now this is what they normally tell you. They say dissolve 4 to 5 cubic centimeters. Now this is what students do. They tell you, you are dissolving 5, let me say 5 cubic centimeters. Someone gets a ruler. You get a ruler and you measure your 5. So that is wrong. Ruler is measuring length, not volume. You understand? So you don't need to get a ruler and you start measuring the 5. That is one. Number two, someone may ask for a measuring cylinder. It's okay. Okay, they have told me to measure 5. Where's the measuring cylinder? Then you don't have it, then you are stuck. No, you can just estimate. You understand? So you can estimate maybe 1 cubic centimeter can be around here. Now, if they are 5, could be maybe 1, 2, 3. You can try to estimate. You understand? So and then you do what? You dissolve. But I've said it's all about estimation. You can estimate. Then they said you do what? You shake. Now, how do you shake? You put the finger like this, and you do the shaking. You understand? So you don't need to fear unless if it is an acid, and you know acids for them, you don't need to shake. They dissolve by themselves. If I was having a carbonate here, Let me see. Not the other carbonate can dissolve in water, but let me try it. So now are you seeing this one? That if I do this, it dissolves very fast. But if you try to do, there is a way people shake, and then you waste a lot of time on shaking. So let me try to get a carbonate. Yeah. Now, I want to show you how do you dissolve a substance with an acid. Are you there? How do you dissolve with an acid? Someone with a test tube to help me. A spatula? Okay. Now this is the carbonate. Are you there? This carbonate can dissolve in water. You understand? But basically I just wanted to show you how we dissolve a substance with an acid. So I have nitric acid here. Now, in the Unable practical, we may not be having these bottles which are having like a dropper, like this one. So we will be having these droppers, these ones. Now, some students don't know how to use a dropper, but I think for you, you know. So how do we use a dropper? You first press it. Are you seeing it? Then you put it in the chemical and you release it. Then it sucks by itself. So you can start fidgeting, sucking, and then when time is going. So you press it, you put it there, and then it sucks by itself. You understand? And you suck enough. Now we are dissolving. Now, how do we hold the test tubes? We hold them like this. You understand? When you are holding, you hold like this so that you see what you are adding, not like this. Like this, and then I add. Now, when you're adding an acid, we see some effervescence. You know effervescence? You see bubbles like opening a bottle of soda. So you add a little bit slowly. Are you seeing it? Now, if you just pour like this down, you will see the bubbles, and then you try to throw away the test tube. So like this, members, this is what you need to know. Whenever you add an acid in the chemical and you see this kind of thing, you confirm that in that chemical there is a carbonate. It is the only one which can do this. Have you got that one? If they give you a carbonate, a substance, they tell you to dissolve with an acid, and you see this kind of thing, you confirm in that compound there is a carbonate. You get it? So I have dissolved it. Now, if you still see the effervescence, you keep on adding. You understand? Yeah, you keep on adding. So that is that. So, sorry. I've illustrated how we dissolve. So you can go and dissolve very fast. Within a minute, then you come back.